Welcome back to After Hours Engineering. In this video series, we accomplished what we set out to do, to build a softcore processor, the A09. It was challenging and yet satisfying, and what a journey it was. Yet After Hour Engineering has many more things to do, not just with the A09, but with other projects relating to FPGAs and others relating to neuromorphic engineering. In order to organize future journeys and catch up on other projects and contracts, I'm going to have to pause on video creation for just a few weeks so I can brainstorm on what the next journey is. In the meantime, I've organized the code and placed it up onto GitHub. In addition, I've taken the liberty to flush out some ideas and potential candidates which relate to FPGAs and CPUs. Let's take a look at some of those. One candidate is to carry on the theme and analyze an existing design, the RISC-V ISA. It comes in many different flavors: Serve, Hazard3, Femto, Pico-RV. There are many implementations of RISC-V out there. Some as simple as what we've done, the RV32i, all the way up to Wishbones and AXI buses. Or we could look at it from a different perspective, the Cilushdl. It's a new HDL language that tries to add a level of quality of service to such languages as Verilog, including it accepts Verilog modules as in its design, which is great. They have the ICE5. Perhaps we could look at communication channels like SPI displays, UART, I2C, DVI HDMI. Or maybe we could combine two breakout boards and create some sort of Frankenstein, like one could be the CPU and the other one could be a GPU hooked up to either VGA or HDMI. Or we could look at I/O components, and there are a lot of those. External RAM via an MMU, SPI RAM, SRAM, HyperRAM, rotary encoder, switching to bouncing, parallel debouncing and displays, raw displays, capacitive touch interfaces, audio, which is another potential protocol, either using no protocol at all or I2S. Or we could continue with the A09 with performance and optimization enhancements, I/O, or even programmable I/O like the Pico 2040. Timers, interrupts, memory, again, SRAM, PRAM, HyperRAM. And then maybe it's a work in progress, something to deal with neuromorphic engineering. I'm not sure if I'll split that off into a separate playlist, but we would look at maybe neuron simulations on an FPGA and in a specific language like Go. And then maybe even look at the temporal neural network designed by Professor James E. Smith. I really like that. It's a very simple design and approachable. It certainly looks like there are plenty of options. What road we take is yet to be set in stone, but at least we have plenty to choose from. Finally, I appreciate all my subscribers for hanging in there. And above all, I am humbled because you have subscribed. Thank you very much. And there will be a next time